Question 1. Process analysis reveals that a proposed data center infrastructure design for a financial services organization prioritizes rapid deployment and cost savings above all else. The design includes a single, high-performance network core without redundant links or devices, and relies on basic firewalling without advanced intrusion detection or prevention systems. The organization operates under strict data integrity and availability mandates, which approach to the impact assessment phase of this design process best aligns with professional best practices and regulatory expectations for such an environment. Option A. Evaluate the potential impact of security vulnerabilities only in terms of the likelihood of a breach, without quantifying the potential financial or operational consequences of such a breach. Option B. Prioritize the assessment of the performance benchmarks of the chosen network core, ensuring it can handle peak loads, and consider the impact assessment complete once these benchmarks are met. Option C. Focus the impact assessment primarily on the cost savings achieved by the simplified design, documenting how the chosen components meet the minimum functional requirements for data transmission. Option D. Conduct a comprehensive impact assessment that identifies critical business functions, potential failure points in the proposed design, and the cascading effects of outages on data integrity and availability, cross-referencing these impacts with relevant financial industry regulations and compliance requirements. The correct answer is D. Conduct a comprehensive impact assessment that identifies critical business functions, potential failure points in the proposed design, and the cascading effects of outages on data integrity and availability, cross-referencing these impacts with relevant financial industry regulations and compliance requirements. Explanation. This scenario is professionally challenging because the impact assessment for a data center infrastructure design must consider a wide range of potential consequences, from operational disruption to regulatory compliance failures. The Cisco 300-610 DCID exam focuses on designing robust and resilient data center solutions, which inherently requires a thorough understanding of how design choices affect business continuity, security, and adherence to industry standards. Careful judgment is required to prioritize mitigation strategies and ensure that the proposed design meets all functional and non-functional requirements, including those related to compliance and risk management. The correct approach represents best professional practice because it systematically evaluates the potential impact of various design elements on critical business functions and regulatory obligations. By identifying and quantifying risks, it allows for informed decision-making regarding the implementation of appropriate controls and redundancies. This proactive approach ensures that the data center infrastructure is not only technically sound, but also compliant with relevant regulations and resilient to disruptions, thereby safeguarding the organization's operations and reputation. This aligns with the principles of responsible data center design, emphasizing reliability, security, and compliance as core tenets. An incorrect approach that focuses solely on cost reduction without a comprehensive impact assessment would be professionally unacceptable. This failure stems from a disregard for potential business disruptions and regulatory penalties. For instance, neglecting the impact of a single point of failure in a critical network path could lead to significant downtime, resulting in substantial financial losses and potential breaches of service-level agreements, SLAs. Furthermore, if the design fails to meet data privacy regulations, e.g., GDPR if this were a European context, or relevant U.S. federal/state laws if U.S. jurisdiction, the organization could face severe fines and legal repercussions. Another incorrect approach that prioritizes cutting-edge technology over proven stability would also be professionally unsound. While innovation is important, implementing unproven technologies without a thorough impact assessment on reliability and security introduces unacceptable risks. A failure in a novel, untested component could have cascading effects throughout the data center, leading to widespread outages and data integrity issues. This demonstrates a lack of due diligence and a failure to uphold the professional responsibility to design secure and reliable systems. The professional decision-making process for similar situations should involve a structured risk assessment framework. This framework should begin with identifying all potential design elements and their associated functions. Subsequently, for each element, potential failure modes and their impacts on business operations, security, and compliance must be analyzed. This analysis should consider both direct and indirect consequences. Based on this impact assessment, Appropriate mitigation strategies, such as redundancy, failover mechanisms, security controls, and monitoring solutions, should be identified and prioritized. The final design should reflect a balance between performance, cost, resilience, and compliance, ensuring that all identified risks are adequately addressed to an acceptable level. Question 2. The evaluation methodology shows that when designing a new data center network fabric, a critical step is to assess the potential impact of the proposed design on existing operational processes and future scalability. Which of the following approaches best addresses this requirement? Option A. Focus exclusively on achieving the highest possible network throughput and lowest latency, as these are the primary metrics for modern data center performance. Option B. Implement the new design with minimal disruption to current operations, deferring any comprehensive impact assessment until after the system has been deployed and is in production. Option C. Conduct a detailed analysis of potential performance bottlenecks, security vulnerabilities, and availability risks, while also evaluating the integration with existing management tools and the design's capacity for future expansion. Option D. Prioritize the selection of the most cost-effective network hardware to minimize initial capital expenditure, assuming that future scalability can be addressed with subsequent upgrades. Correct answer is C. Conduct a detailed analysis of potential performance bottlenecks, security vulnerabilities, and availability risks, while also evaluating the integration with existing management tools and the design's capacity for future expansion. Explanation. The evaluation methodology shows the critical need for a structured approach to impact assessment when designing data center infrastructure. This scenario is professionally challenging because the rapid pace of technological evolution and the interconnectedness of data center components mean that even seemingly minor changes can have cascading and unforeseen consequences on performance, security, and availability. A thorough impact assessment is not merely a technical exercise. It's a fundamental requirement for ensuring compliance with operational standards and risk management frameworks. The correct approach, which involves a comprehensive analysis of potential impacts across all relevant domains, performance, security, availability, manageability, and cost, represents best professional practice. This aligns with industry best practices and regulatory expectations for robust design and risk mitigation. Specifically, in the context of data center design, this systematic evaluation ensures that potential disruptions are identified and addressed proactively, minimizing the likelihood of service outages, data breaches, or performance degradation. This proactive stance is essential for maintaining business continuity and meeting service level agreements, SLAs, which are often implicitly or explicitly governed by industry standards and customer contracts. An incorrect approach that focuses solely on immediate performance gains without considering security implications would be professionally unacceptable. This failure represents a significant regulatory and ethical lapse because it neglects the fundamental responsibility to protect sensitive data and maintain the integrity of the data center's operations. Such an oversight could lead to vulnerabilities that are exploited, resulting in data breaches, financial losses, and reputational damage, all of which can have legal ramifications. Another incorrect approach, which prioritizes cost reduction by omitting redundancy measures, is also professionally unsound. This decision demonstrates a disregard for availability requirements and business continuity planning. In the event of a component failure, the lack of redundancy would lead to an unacceptable downtime, violating service-level agreements and potentially incurring penalties. Ethically, it fails to uphold the duty of care to ensure reliable service delivery. A third incorrect approach, which overlooks the impact on existing management and monitoring tools, is also problematic. This oversight can lead to significant operational challenges, making it difficult to detect, diagnose, and resolve issues in the new infrastructure. This can result in prolonged outages and increased operational costs, demonstrating a lack of foresight and a failure to consider the holistic operational environment. The professional decision-making process for similar situations should involve a multidisciplinary team, including network engineers, security specialists, operations personnel, and business stakeholders. This team should collaboratively define the scope of the impact assessment, identify potential risks and their likelihood, and evaluate the severity of potential consequences. The process should be iterative, with findings from the assessment feeding back into the design process to refine solutions and mitigate identified risks. Documentation of the assessment process and its outcomes is crucial for accountability and future reference. Question 3. The risk matrix shows a high likelihood of lateral movement of threats within the data center network if a compromise occurs. Considering the need to protect sensitive customer data and adhere to data privacy regulations, which network segmentation strategy best mitigates this risk while ensuring operational efficiency? Option A. Implement microsegmentation based on application workloads and data sensitivity, creating granular security zones around individual applications and their associated data stores. Option B. Rely solely on traditional VLAN-based segmentation at the network edge to isolate different departments and server groups. Option C. Implement a broad, flat network architecture with minimal segmentation to reduce complexity and improve network performance. Option D. Utilize physical network separation for critical application, with minimal, logical segmentation within those physical boundaries. The correct answer is A. Implement microsegmentation based on application workloads and data sensitivity, creating granular security zones around individual applications and their associated data stores. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for network resilience and performance with the long-term implications of technology choices, all within the context of a specific regulatory framework. The chosen topic, network segmentation, is critical for data center security and compliance. The challenge lies in selecting a segmentation strategy that not only meets current operational demands, but also aligns with the principles of data protection and privacy as mandated by relevant regulations, without introducing undue complexity or operational overhead. Careful judgment is required to ensure that the chosen solution is both effective and compliant. The correct approach represents best professional practice because it prioritizes a layered security model that aligns with the principles of least privilege and data segregation. By implementing microsegmentation based on application workloads and data sensitivity, the design directly addresses the regulatory requirement to protect sensitive data and limit the blast radius of potential security incidents. This approach is proactive, scalable, and demonstrably reduces the attack surface, which is a key tenet of robust data center infrastructure design and a common expectation in regulatory compliance frameworks focused on data security. An incorrect approach that relies solely on traditional perimeter-based segmentation fails to adequately address modern threats that can bypass network perimeters. This approach is professionally unacceptable because it creates a false sense of security and leaves internal network segments vulnerable, potentially leading to regulatory violations if sensitive data is compromised. It demonstrates a lack of understanding of current threat landscapes and the evolving expectations of regulatory bodies regarding internal network controls. Another incorrect approach that focuses only on physical network separation without considering logical segmentation is also professionally unacceptable. While physical separation can enhance security, it is often impractical and cost-prohibitive in modern, dynamic data center environments. More importantly, it fails to address the need for granular control over traffic flows between applications and services, which is essential for compliance with data protection regulations that mandate controls over data access and movement. This approach is outdated and does not reflect best practices in data center design. A third incorrect approach that prioritizes cost savings over security and compliance by implementing minimal segmentation is professionally unacceptable. This demonstrates a failure to adequately assess and mitigate risks, directly contravening the professional responsibility to design secure and compliant infrastructure. Such a decision could lead to significant financial penalties and reputational damage if a security breach occurs, highlighting a critical ethical and professional failing. Professional decision-making process for similar situations should involve a thorough risk assessment that considers both technical vulnerabilities and regulatory requirements. This should be followed by an evaluation of various design options against these criteria, prioritizing solutions that offer robust security, scalability, and compliance. Collaboration with security and compliance teams is essential to ensure that the chosen design meets all necessary standards. The decision should be documented, including the rationale for the chosen approach and the justification for rejecting alternatives, to demonstrate due diligence and accountability. Question 4. Benchmark analysis indicates that a financial services organization is experiencing performance degradation and increased latency in its primary data center, impacting critical trading applications. The current infrastructure relies on a mix of legacy hardware and a disparate network fabric. The organization requires a redesign that enhances application performance, improves network resilience, and simplifies management, while ensuring compliance with industry standards for financial data processing. The design must leverage Cisco technologies as the core of the data center infrastructure. Which of the following design approaches best addresses these requirements within the context of designing a Cisco data center infrastructure? Option A. Implement a unified fabric using Cisco Nexus switches and Cisco application-centric infrastructure. ASI, to provide a policy-driven, automated network and compute environment, integrating with validated Cisco storage solutions for optimal performance and resilience. Option B. Adopt a multi-vendor approach, integrating open-source networking solutions with commodity hardware to achieve maximum cost savings and flexibility, while relying on custom scripting for automation. Option C. Deploy a purely software-defined networking (SDN) solution from a non-Cisco vendor, focusing on abstracting the underlying hardware and providing a vendor-agnostic management layer. Option D. Upgrade existing legacy hardware with minimal changes to the network topology, focusing on increasing individual component specifications without a holistic fabric redesign. The correct answer is A. Implement a unified fabric using Cisco Nexus switches and Cisco application-centric infrastructure, ASI, to provide a policy-driven, automated network and compute environment, integrating with validated Cisco storage solutions for optimal performance and resilience. Explanation. This scenario presents a common challenge in data center design, balancing performance requirements with the need for robust, resilient, and compliant infrastructure. The professional challenge lies in interpreting and applying the specific requirements of the 300-610 DCID exam syllabus, which implicitly guides the design towards best practices in Cisco data center technologies, without introducing external, non-applicable regulatory frameworks. The core of the decision-making process involves understanding the implications of different design choices on the overall data center's availability, scalability, and manageability, all within the context of the exam scope. The correct approach represents best professional practice because it aligns with the fundamental principles of data center design as taught and tested by Cisco's DCID certification. This involves selecting technologies and configurations that are proven, well-supported, and designed for high availability and performance. Specifically, leveraging Cisco's validated designs and recommended practices for technologies like Nexus switches, ASI, and storage integration ensures a stable, predictable, and efficient data center environment. This approach prioritizes interoperability, simplifies troubleshooting, and reduces the risk of unforeseen issues, all of which are critical for production data center. Adhering to these established best practices is implicitly mandated by the exam's focus on designing robust data center infrastructure. Each incorrect approach represents a failure to adhere to the principles of sound data center design, as expected within the scope of the 300-610 DCID exam. One incorrect approach might involve prioritizing a vendor-agnostic solution without sufficient consideration for the deep integration and specific features offered by Cisco's ecosystem, which is the focus of the exam. This can lead to suboptimal performance, compatibility issues, and increased complexity in management and troubleshooting. Ethically, it represents a failure to leverage the expertise and validated solutions that the exam is designed to assess. Another incorrect approach could be to implement a design based solely on cost reduction without a thorough risk assessment of its impact on availability and performance. This is professionally unsound, as it can lead to increased downtime, higher operational expenses in the long run due to remediation, and a failure to meet the core business requirements for a resilient data center. It violates the implicit ethical obligation to design for reliability and business continuity. A third incorrect approach might be to adopt bleeding-edge or unproven technologies without adequate testing and validation. While innovation is important, a production data center design must prioritize stability and proven solutions. This approach risks significant operational disruption and can be seen as professionally negligent, as it exposes the organization to unnecessary risks that could have been avoided by following established design patterns. The professional decision-making process for similar situations should involve a thorough understanding of the project's requirements, a deep knowledge of the available technologies and their best practices, especially those relevant to the exam scope, a comprehensive risk assessment for each design option, and a clear understanding of the long-term operational implications. Professionals should always strive to align their designs with vendor-recommended architectures and validated solutions when available, particularly when preparing for or working within a specific vendor's ecosystem, as is the case with Cisco's DCID. Question 5. The audit findings indicate a potential gap in the data center's network segmentation strategy, which could inadvertently expose sensitive customer data to unauthorized access, thereby posing a risk of noncompliance with U.S. data protection regulations. The design team is considering several approaches to address this finding. Which of the following approaches best represents a professional and compliant resolution to the audit finding? Option A. Introduce a new security appliance that promises to broadly enhance network security, without a detailed assessment of how it specifically addresses the identified segmentation vulnerabilities or its integration with the existing infrastructure. Option B. Defer the remediation of the segmentation issue until the next major infrastructure refresh cycle to minimize immediate disruption and cost, relying on existing security measures to provide adequate protection in the interim. Option C. Implement a comprehensive review of the existing network architecture, identify specific vulnerabilities related to segmentation, and propose a phased implementation of enhanced network segmentation controls, including updated firewall rules and access control lists, with thorough testing and validation before full deployment. Option D. Apply a broad network access control policy across all segments, assuming this will mitigate the risk without detailed analysis of the specific segmentation gaps identified by the audit. The correct answer is C. Implement a comprehensive review of the existing network architecture, identify specific vulnerabilities related to segmentation, and propose a phased implementation of enhanced network segmentation controls, including updated firewall rules and access control lists, with thorough testing and validation before full deployment. Explanation. This scenario presents a professional challenge due to the critical nature of data center infrastructure design and the potential impact of design choices on compliance with regulatory frameworks. The auditor's findings highlight a gap in the current design that could lead to noncompliance, necessitating a careful and informed decision on how to address the issue. The challenge lies in balancing operational efficiency, cost, and adherence to the specific regulatory requirements relevant to the data center's operational context, which for this exam is assumed to be within the United States. The correct approach represents best professional practice because it directly addresses the identified audit finding by proposing a solution that aligns with established industry best practices for data center design and security, specifically within the U.S. regulatory landscape. This approach prioritizes a thorough assessment of the impact of the proposed changes on the overall infrastructure, ensuring that any remediation efforts do not introduce new vulnerabilities or compliance issues. It also involves engaging relevant stakeholders, which is crucial for successful implementation and for demonstrating due diligence in meeting regulatory obligations. This proactive and comprehensive method ensures that the data center's design remains robust, secure, and compliant with relevant U.S. federal and state regulations governing data handling and infrastructure. An incorrect approach that focuses solely on a quick fix without understanding the underlying cause or potential ripple effects is professionally unacceptable. This could lead to a superficial resolution that fails to address the root of the audit finding, potentially resulting in recurring issues or the introduction of new security or compliance risks. Such an approach might also overlook the interdependencies within the data center infrastructure, leading to unintended consequences that could violate specific U.S. regulations like HIPAA for healthcare data, PCI DSS for payment card data, or NIST guidelines for federal information systems, depending on the data center's function. Another incorrect approach that prioritizes cost savings over compliance is ethically and professionally unsound. While cost is a factor in any design, it should never supersede the requirement to meet regulatory obligations. Failing to invest in necessary infrastructure upgrades or security measures to comply with U.S. laws and standards can expose the organization to significant legal penalties, reputational damage, and loss of customer trust. This demonstrates a lack of professional responsibility and a disregard for the legal and ethical obligations associated with data center operations. A third incorrect approach that involves implementing a solution without proper testing or validation is also professionally deficient. This can lead to unforeseen operational disruptions, security vulnerabilities, or even a failure to achieve the intended compliance outcome. In the U.S. regulatory environment, demonstrating that controls are effective and have been properly tested is often a requirement for compliance. A rushed implementation without validation suggests a lack of rigor and a failure to exercise due professional care. The professional decision-making process for similar situations should involve a structured approach. First, thoroughly understand the audit finding and its implications within the relevant U.S. regulatory framework. Second, identify potential solutions, evaluating each for its technical feasibility, cost-effectiveness, and most importantly, its ability to achieve and maintain compliance. Third, consult with subject matter experts and stakeholders to gain a comprehensive understanding of the impact of each solution. Fourth, select the solution that best balances operational needs with regulatory requirements and implement it with rigorous testing and validation. Finally, document the entire process and the rationale for the chosen solution to demonstrate due diligence and compliance. Question 6. Strategic planning requires a comprehensive evaluation of data center infrastructure deployment models to meet evolving business demands, while strictly adhering to data residency and privacy regulations. Given an organization operating under U.S. federal and state data protection laws, which of the following approaches best ensures compliance and operational integrity? Option A. Prioritize a hybrid cloud model that leverages public cloud services for scalability and cost efficiency, while ensuring sensitive data is stored and processed within U.S.-based data centers, with contractual agreements explicitly defining data sovereignty and access controls. Option B. Implement an on-premises data center solution to maintain complete physical control over all data, even if it leads to higher operational costs and slower scalability compared to cloud alternatives. Option C. Adopt a purely public cloud strategy, relying on the cloud provider's global infrastructure to offer the best performance and cost, assuming their standard compliance certifications are sufficient for all data types. Option D. Select a private cloud solution hosted in a region outside the U.S. to benefit from lower operational costs and potentially more flexible regulatory environments, without explicit consideration for U.S. data residency laws. The correct answer is A. Prioritize a hybrid cloud model that leverages public cloud services for scalability and cost efficiency, while ensuring sensitive data is stored and processed within U.S.-based data centers, with contractual agreements explicitly defining data sovereignty and access controls. Explanation. This scenario presents a professional challenge in designing a data center infrastructure that balances evolving business needs with the stringent requirements of data residency and privacy regulations. The core difficulty lies in selecting a deployment model that not only meets performance and scalability demands, but also ensures compliance with the specific data protection laws applicable to the organization's operating jurisdiction. Careful judgment is required to avoid costly remediation or legal repercussions. The correct approach represents best professional practice because it prioritizes a thorough understanding of the regulatory landscape before committing to a specific infrastructure design. By engaging legal counsel and compliance officers early, the organization ensures that the chosen data center design adheres to all applicable data residency, privacy, and security mandates. This proactive stance minimizes the risk of noncompliance, which can lead to significant fines, reputational damage, and operational disruptions. It aligns with the ethical obligation to protect sensitive data and uphold legal requirements. An incorrect approach that focuses solely on cost optimization without considering regulatory implications is professionally unacceptable. This failure stems from a disregard for legal obligations, potentially leading to violations of data residency laws, which mandate that certain data must remain within specific geographical boundaries. Such a failure could result in severe penalties and loss of customer trust. Another incorrect approach that prioritizes immediate scalability over compliance is also professionally unacceptable. This overlooks the fundamental requirement to protect data according to legal frameworks, ignoring data privacy regulations, such as those governing the handling of personal identifiable information, PI, can lead to breaches of trust and legal action. professional reasoning framework for such situations involves a multidisciplinary approach. First, clearly define the business requirements for performance, scalability, and availability. Second, conduct a comprehensive assessment of all relevant regulatory frameworks, consulting with legal and compliance experts to understand data residency, privacy, and security obligations. Third, evaluate potential infrastructure designs, e.g., on-premises, private cloud, public cloud, hybrid, against both business requirements and regulatory constraints. Fourth, select the design that best balances these competing demands, ensuring that compliance is a non-negotiable element. Finally, implement robust monitoring and auditing mechanisms to ensure ongoing adherence to regulations. Question 7. Governance review demonstrates a critical need to enhance the resilience of a newly designed Cisco data center infrastructure. The primary business objective is to minimize unplanned downtime for core business applications. Considering the principles of designing Cisco data center infrastructure, DCID, which approach best achieves this objective by ensuring continuous operation in the face of component failures. Option A. Focus exclusively on application-level high-availability features, trusting that the underlying infrastructure will inherently tolerate failures. Option B. Implement redundant network paths and compute resources across multiple availability zones within the data center, ensuring active-active or active-passive configurations for critical services. Option C. Establish a disaster recovery site and assume that its existence negates the need for robust high availability within the primary data center. Option D. Deploy a single, highly available core network switch with redundant power supplies and supervisors, assuming this is sufficient for network resilience. The correct answer is B. Implement redundant network paths and compute resources across multiple availability zones within the data center, ensuring active-active or active-passive configurations for critical services. Explanation. Scenario analysis. This scenario presents a common challenge in data center design, where the need for high availability and disaster recovery must be balanced against the cost and complexity of implementation. The professional challenge lies in interpreting and applying the principles of redundancy and resilience in a way that meets business objectives and regulatory compliance without over-engineering or under-provisioning. The requirement to adhere strictly to the 300-610 DCID exam scope means focusing on the design principles and technologies relevant to Cisco data center infrastructure, rather than generic IT best practices or external regulations not covered by the exam. Correct approach analysis. The correct approach involves designing for active-active or active-passive redundancy at critical layers of the data center infrastructure, specifically focusing on network and compute resources. This aligns with the DCID syllabus's emphasis on designing for high availability, fault tolerance, and disaster recovery, implementing redundant network paths, e.g., using technologies like VPC Fabric Path or BGP FBAN with multi-homing, ensures that a single link or device failure does not disrupt connectivity. Similarly, redundant compute resources, e.g., server clustering, virtual machine high availability, ensure that application services remain available if a host fails. This approach directly addresses the core tenets of data center resilience as taught in the DCID curriculum, ensuring business continuity and minimizing downtime. Incorrect approach is analysis. Implementing a single, highly resilient core network device without redundant paths to downstream devices is a failure because it creates a single point of failure. While the core device itself might be redundant internally, the lack of redundant links to other network segments means that a failure in those links or the connected devices would still lead to an outage. This violates the principle of end-to-end redundancy. Designing for redundancy only at the application layer, assuming the underlying infrastructure is inherently fault-tolerant, is also incorrect. The DCID curriculum emphasizes that resilience must be built into the entire data center stack, from the physical layer through the network, compute, and storage. Relying solely on application-level HA mechanisms ignores potential infrastructure failures that could cascade and impact application availability. Focusing solely on disaster recovery sites without adequate high availability within the primary data center is another flawed approach. While DR is crucial, it typically involves longer recovery times and is designed for catastrophic events. A primary data center that lacks robust HA capabilities will experience frequent, short-duration outages due to common hardware or software failures, which DR sites are not designed to mitigate effectively. This leads to unacceptable downtime for routine operational issues. Professional reasoning. Professionals should approach data center design by first understanding the business's availability requirements, recovery time objective RTO, and recovery point objective RPO, and then mapping these requirements to the DCID syllabus's design principles for high availability, redundancy, and disaster recovery. A layered approach, ensuring redundancy at each critical infrastructure component, network, compute, storage, is paramount. This involves selecting appropriate Cisco technologies and design patterns that provide fault tolerance and resilience. Regular review and testing of these designs are essential to validate their effectiveness and ensure they meet evolving business needs and technological advancements within the scope of the DCID framework. Question 8. Assessment of which storage solution design approach best aligns with the principles of regulatory compliance and data governance for a new data center infrastructure deployment in a jurisdiction with stringent data residency and privacy laws. Option A. Opting for a storage solution based on its widespread adoption and positive market reviews, with the assumption that it inherently meets most regulatory standards. Option B. Choosing a storage solution that has been independently certified for compliance with relevant data residency and privacy regulations and offers robust data protection and audit capabilities. Option C. Prioritizing the most cost-effective storage solution available, assuming that regulatory requirements can be met through software configurations after deployment. Option D. Selecting a storage solution that offers the highest performance metrics and scalability, with the understanding that compliance features can be retrofitted if required. The correct answer is D. Selecting a storage solution that offers the highest performance metrics and scalability, with the understanding that compliance features can be retrofitted if required. Explanation. Scenario analysis. Designing a data center infrastructure involves significant capital expenditure and impacts the organization's ability to meet business objectives, including compliance with various regulations. The challenge lies in selecting a storage solution that balances performance, scalability, cost, and crucially, adherence to data residency and privacy regulations. Misinterpreting or overlooking these requirements can lead to severe legal penalties, reputational damage, and operational disruptions. The professional must navigate technical requirements alongside a complex regulatory landscape, demanding a thorough understanding of both. Correct approach analysis. The correct approach prioritizes understanding and adhering to the specific regulatory framework governing data storage and processing for the organization's operating jurisdiction. For a Cisco DCID exam, this implies focusing on the regulatory environment relevant to the Cisco ecosystem and its typical deployments, which often implies U.S. federal and state regulations, or international standards if specified. A solution that explicitly addresses data residency requirements, such as ensuring data is stored within a defined geographical boundary, as mandated by regulations like GDPR, if applicable to the jurisdiction, or specific U.S. state privacy laws, and incorporates appropriate security controls to protect sensitive data, represents best professional practice. This demonstrates a commitment to legal compliance and risk mitigation, which are paramount in data center design. Incorrect approach is analysis. Focusing solely on performance metrics without considering regulatory compliance is a significant ethical and professional failure. For instance, selecting a storage solution based purely on IOPS or throughput, without verifying if it can meet data residency mandates or provide the necessary audit trails required by regulations, exposes the organization to noncompliance. This approach disregards the legal obligations of data handling, prioritizing cost-effectiveness above all else, without a comprehensive assessment of regulatory implications, is another critical failure. While cost is a factor, it cannot supersede legal requirements. A cheaper solution that violates data privacy laws or residency rules will ultimately be far more expensive due to fines and remediation efforts. This demonstrates a lack of due diligence and a disregard for the organization's legal standing. Choosing a solution based on vendor marketing claims without independent verification of its compliance capabilities is also professionally unsound. Vendors may highlight features that can be configured for compliance, but the responsibility for ensuring actual compliance rests with the designer and the organization. Relying on unsubstantiated claims without due diligence can lead to a false sense of security and eventual noncompliance. Professional reasoning. Professionals designing data center infrastructure must adopt a risk-based approach. This involves 1. Identifying all applicable regulatory frameworks based on the organization's location, industry, and the type of data being handled. 2. Translating these regulatory requirements into specific technical design constraints and functional needs for the data center infrastructure. 3. Evaluating potential solutions against these technical and regulatory requirements, not just performance or cost. 4. Documenting the rationale for design choices, clearly demonstrating how regulatory compliance has been addressed. 5. Engaging with legal and compliance teams to validate the design's adherence to all relevant laws and guidelines. Question 9. Comparative studies suggest that when designing a new data center storage infrastructure, a critical decision involves selecting the most appropriate technology. Considering the need for high performance, scalability, and cost-effectiveness, which of the following design approaches best aligns with industry best practices and Cisco's recommended methodologies for data center infrastructure? Option A. Select the storage solution with the lowest initial purchase price, assuming that future needs can be addressed with incremental upgrades as they arise. Option B. Prioritize a comprehensive evaluation of various storage technologies, including their performance characteristics, scalability options, data protection capabilities, and total cost of ownership, to identify the solution that best meets current and future requirements. Option C. Opt for a proprietary storage solution from a single, well-established vendor to ensure seamless integration and simplify management, without extensive comparison with alternative offerings. Option D. Focus exclusively on meeting the immediate performance demands of the most critical applications, deferring considerations for scalability and broader data center integration to a later phase. The correct answer is B. Prioritize a comprehensive evaluation of various storage technologies, including their performance characteristics, scalability options, data protection capabilities, and total cost of ownership, to identify the solution that best meets current and future requirements. Explanation. The scenario presents a common challenge in data center design, balancing performance requirements with cost-effectiveness and adherence to evolving industry standards. The professional challenge lies in selecting a storage solution that not only meets current application demands, but also offers scalability, resilience, and aligns with the organization's long-term strategic goals and budget constraints, all while considering the implications of vendor lock-in and the potential for future technology shifts. Careful judgment is required to avoid over-provisioning or under-provisioning, which can lead to significant financial waste or operational deficiencies. The correct approach represents best professional practice because it prioritizes a holistic evaluation of storage technologies. This involves a thorough assessment of performance metrics, IOPS, latency, throughput, scalability options, data protection features, snapshots, replication, and integration capabilities with existing infrastructure. Furthermore, it considers the total cost of ownership, TCO, including initial purchase, maintenance, power, cooling, and potential future upgrade costs. Adherence to industry best practices and Cisco's recommended design principles for data center infrastructure, as outlined in the DCID curriculum, ensures a robust, reliable, and future-proof solution. This approach minimizes risk and maximizes the return on investment by selecting a solution that is technically sound and economically viable. An incorrect approach that focuses solely on the lowest upfront cost fails to consider the long-term implications. This can lead to higher operational expenses, performance bottlenecks, and the need for premature upgrades, ultimately increasing the TCO and potentially impacting application performance and user experience. This approach represents a failure in due diligence and a disregard for sound financial and technical planning, which are ethical considerations in professional design. Another incorrect approach that prioritizes a single vendor's proprietary solution without adequate comparative analysis risks vendor lock-in. This can limit future flexibility, potentially leading to higher costs for upgrades or replacements, and hindering the adoption of more innovative or cost-effective technologies from other vendors. Ethically, this can be seen as a failure to act in the best interest of the organization by not exploring all viable options and potentially creating a dependency that is detrimental in the long run. Finally, an approach that neglects to consider the scalability and future growth needs of the data center is also professionally unsound. This can result in a system that quickly becomes inadequate, requiring costly and disruptive retrofits or replacements. This demonstrates a lack of foresight and a failure to design for the evolving needs of the business, which is a core responsibility of a data center designer. The professional reasoning process for similar situations should involve a structured, multifaceted evaluation. This includes clearly defining the requirements, performance, capacity, availability, security, identifying potential solutions from various vendors and technologies, conducting a thorough comparative analysis based on defined criteria, technical capabilities, TCO, scalability, support, risk, and finally, making a recommendation supported by data and a clear justification that aligns with the organization's strategic objectives and constraints. Question 10. The performance metrics show a consistent increase in application response times and occasional packet loss during peak usage hours, impacting user experience and critical business operations. The current data center network infrastructure includes Nexus switches for core and aggregation layers, and Catalyst switches for the access layer, with a mix of 10 Gbps and 40 Gbps links. The design team is tasked with identifying the most effective strategy to address these performance degradations. Option A. Rely on historical data from previous network upgrades and implement a similar solution, assuming the underlying issues are consistent with past performance problems. Option B. Immediately upgrade all core and aggregation Nexus switches to the latest generation with higher port densities and faster throughput, assuming the current hardware is the primary limitation. Option C. Conduct a detailed analysis of network traffic patterns, latency, and packet loss at different points in the infrastructure, correlating findings with application behavior, and propose targeted Co-S policies and potential topology optimizations to address identified bottlenecks. Option D. Increase the bandwidth of all uplinks between the access and aggregation layers by replacing existing 10 Gbps links with 40 Gbps links, without further investigation into the root cause of the performance issues. The correct answer is C. Conduct a detailed analysis of network traffic patterns, latency, and packet loss at different points in the infrastructure, correlating findings with application behavior, and propose targeted Co-S policies and potential topology optimizations to address identified bottlenecks. Explanation. Scenario analysis. This scenario presents a common challenge in data center design, balancing performance requirements with cost-effectiveness and adherence to evolving industry best practices. The challenge lies in interpreting performance metrics, understanding the underlying causes of degradation, and proposing solutions that are not only technically sound, but also align with the organization's strategic goals and the principles of efficient resource utilization. The pressure to deliver a robust and scalable solution while managing budget constraints requires a deep understanding of the technology and its implications. Correct approach analysis. The correct approach involves a systematic investigation of the performance bottlenecks, starting with the most likely culprits in a data center environment. This includes analyzing network latency, packet loss, and throughput at various layers of the infrastructure, identifying specific areas of congestion or inefficiency, such as oversubscribed uplinks, inefficient routing, or suboptimal application traffic patterns, is crucial. Proposing a solution that addresses these identified issues, such as implementing quality of service, Co-S, policies to prioritize critical traffic, optimizing network topology for better flow, or considering hardware upgrades where justified by the data, represents best professional practice. This approach is grounded in data-driven decision-making and a thorough understanding of data center networking principles, ensuring that the proposed solution is targeted and effective. Incorrect approach is analysis. Implementing a blanket upgrade of all network hardware without a clear understanding of the root cause of the performance degradation is a wasteful and unprofessional approach. It fails to address the specific issues and incurs unnecessary costs, violating principles of efficient resource management. This approach lacks the analytical rigor expected of a data center designer, focusing solely on increasing bandwidth without investigating other potential bottlenecks like latency or packet loss is also a flawed strategy. Bandwidth is only one component of network performance, and simply increasing it may not resolve the underlying problem, leading to continued performance issues and wasted investment. This demonstrates a superficial understanding of network performance tuning, ignoring the performance metrics altogether and relying on anecdotal evidence or past experience to propose a solution is highly unprofessional and risky. It bypasses the critical data that could pinpoint the exact problem, leading to potentially ineffective or even detrimental design choices. This approach lacks the data-driven foundation essential for sound engineering decisions. Professional reasoning. Professionals should approach such scenarios by first establishing clear performance baselines and then systematically analyzing deviations. This involves utilizing monitoring tools to gather granular data on network traffic, latency, packet loss, and resource utilization. The next step is to correlate these metrics with application behavior and user experience. Based on this analysis, potential solutions should be identified, evaluated for their effectiveness and cost, and then prioritized. A phased implementation approach, with continuous monitoring and validation, is often the most prudent way to ensure successful outcomes and minimize disruption. This methodical process ensures that decisions are informed, justifiable, and aligned with both technical requirements and organizational objectives. Question 11. To address the challenge of designing a new data center infrastructure that will host sensitive customer financial data, ensuring strict adherence to U.S. regulatory compliance frameworks, which of the following design considerations is the most critical for meeting these obligations? Option A. Implementing a multi-layered security architecture that includes robust access controls, encryption at rest and in transit, and comprehensive logging and auditing capabilities, all documented and validated against relevant U.S. financial data protection regulations. Option B. Focusing primarily on cost-effective hardware solutions and standard IT security practices, assuming that general data protection principles will satisfy regulatory requirements for financial data. Option C. Designing for maximum scalability and future expansion without a detailed upfront assessment of specific regulatory mandates, relying on a build-it-and-they-will-come approach to compliance. Option D. Deploying the latest generation of high-performance networking equipment to ensure optimal data throughput and low latency for all customer applications, with security features configured as a secondary consideration. The correct answer is A. Implementing a multi-layered security architecture that includes robust access controls, encryption at rest and in transit, and comprehensive logging and auditing capabilities, all documented and validated against relevant U.S. financial data protection regulations. Explanation. The scenario presents a common challenge in data center design, balancing the need for robust security and compliance with the practicalities of implementation and cost. Specifically, the challenge lies in interpreting and applying the U.S. regulatory framework, particularly concerning data privacy and security standards relevant to a data center handling sensitive customer information. The professional must navigate the nuances of these regulations to ensure the design meets all legal and ethical obligations without introducing unnecessary complexity or expense. The correct approach involves a thorough understanding of the relevant U.S. regulations, such as HIPAA for healthcare data or PCI DSS for payment card data, depending on the data center's clientele. It requires a proactive engagement with compliance officers and legal counsel to ensure the design incorporates the necessary controls and safeguards. This approach represents best professional practice because it prioritizes adherence to legal mandates, protects customer data, and mitigates the risk of significant financial penalties, reputational damage, and legal action. It demonstrates a commitment to responsible data stewardship and a comprehensive understanding of the regulatory landscape. An incorrect approach might involve assuming that general IT security best practices are sufficient without a specific regulatory review. This fails to account for the stringent, often prescriptive, requirements of U.S. data privacy laws. Another incorrect approach could be to prioritize cost savings over compliance, implementing a design that meets some security objectives but falls short of regulatory mandates. This is ethically and legally unacceptable as it knowingly exposes the organization and its clients to risk. A third incorrect approach might be to implement security measures that are overly complex or technically infeasible without a clear regulatory justification, leading to operational inefficiencies and potential compliance gaps due to implementation errors. The professional decision-making process should involve 1. identifying the specific types of data being processed and stored to determine applicable U.S. regulations. 2. Consulting with legal and compliance teams to gain a definitive understanding of regulatory requirements. 3. Designing the data center infrastructure with these specific requirements as a foundational element, not an afterthought. 4. Documenting all design decisions and their rationale, particularly how they align with regulatory mandates. 5. Regularly reviewing and updating the design to accommodate changes in regulations and threat landscapes. Question 12. Quality control measures reveal that a newly designed data center infrastructure intended to host sensitive financial and healthcare data may not fully align with all applicable U.S. regulatory compliance mandates. Which of the following design approaches best ensures adherence to these mandates? Option A. Focus on a cost-effective design that meets current operational needs, with a plan to address any specific regulatory gaps only if they are identified during future audits. Option B. Conduct a thorough review of all relevant U.S. regulatory frameworks, e.g., SOX, HIPAA, PCI DSS, and design the infrastructure with specific controls and documentation to meet each identified requirement, employing a risk-based approach. Option C. Prioritize the implementation of the most advanced, cutting-edge security technologies available, regardless of specific regulatory requirements, to provide a comprehensive security posture. Option D. Implement a standardized, widely adopted security framework that offers general protection, assuming it will cover most common compliance needs without detailed regulatory mapping. The correct answer is C. Prioritize the implementation of the most advanced, cutting-edge security technologies available, regardless of specific regulatory requirements, to provide a comprehensive security posture. Explanation. Scenario analysis. This scenario presents a common challenge in data center design, balancing the need for robust security and compliance with the practicalities of operational efficiency and cost. The challenge lies in interpreting and applying the specific requirements of the U.S. regulatory framework, particularly those related to data privacy and security in a data center context, without over-engineering or under-delivering on compliance. The pressure to deliver a design that is both technically sound and legally defensible requires a deep understanding of the relevant regulations and their implications for infrastructure choices. Correct approach analysis. The correct approach involves a thorough review of the specific U.S. regulatory frameworks applicable to the data center's intended use and the data it will house. This includes understanding mandates like HIPAA for healthcare data, PCI DSS for payment card information, or SOX for financial reporting, and how they translate into infrastructure design requirements. Best professional practice dictates a risk-based approach, identifying critical data assets and applying controls commensurate with the risk of compromise or noncompliance. This ensures that the design meets legal obligations, protects sensitive information, and avoids costly penalties or reputational damage. The focus on documented policies, procedures, and technical controls directly addresses the auditability and enforceability required by U.S. regulations. Incorrect approach is analysis. Implementing a generic, one-size-fits-all security solution without a specific regulatory assessment is a significant ethical and regulatory failure. It risks non-compliance with specific mandates, leaving the organization vulnerable to penalties and data breaches. This approach demonstrates a lack of due diligence and a failure to understand the nuanced requirements of different regulatory bodies. Focusing solely on the most advanced and expensive security technologies without a clear link to specific regulatory requirements is also professionally unsound. While advanced technology can be beneficial, it can lead to unnecessary costs and complexity, and may not address the specific compliance gaps. This approach can be seen as a failure to exercise prudent financial management and a lack of strategic alignment with regulatory objectives. Ignoring potential regulatory changes or future compliance needs in favor of a short-term, cost-effective solution is a critical ethical and professional lapse. Regulations evolve, and a design that does not account for future compliance demonstrates a lack of foresight and a failure to protect the organization's long-term interests. This can lead to costly redesigns and ongoing compliance issues. Professional reasoning. Professionals designing data center infrastructure must adopt a systematic, risk-informed, and compliance-driven approach. This involves 1. Identifying all applicable U.S. regulatory frameworks based on the data center's function and the types of data it will process or store. 2. Conducting a comprehensive risk assessment to understand potential threats and vulnerabilities. 3. Mapping regulatory requirements to specific infrastructure design choices, including physical security, network segmentation, access controls, and data protection mechanisms. 4. Documenting the design decisions and the rationale behind them, clearly linking them to compliance objectives. 5. Establishing ongoing monitoring, auditing, and review processes to ensure continued compliance and adapt to evolving regulatory landscapes. Question 13. Risk assessment procedures indicate that a critical financial transaction processing application experiences significant financial and reputational damage if unavailable for more than 4 hours, with a maximum acceptable data loss of 1 hour. The organization has a limited budget for disaster recovery infrastructure. Which of the following approaches best aligns with a risk-informed data center design strategy for this application? Option A. Implement a multi-site active-active data center architecture with synchronous replication to ensure near-zero downtime and data loss. Option B. Prioritize the fastest possible implementation of a disaster recovery solution, even if it means deferring a detailed risk assessment until after deployment. Option C. Deploy a single, highly resilient data center with robust local redundancy and backup solutions. Assuming a catastrophic site failure is highly improbable. Option D. Conduct a detailed business impact analysis to determine the acceptable RTO and RPO, and then design a DR solution that meets these objectives within budget constraints, potentially utilizing asynchronous replication or tiered recovery strategies. The correct answer is A. Implement a multi-site active-active data center architecture with synchronous replication to ensure near-zero downtime and data loss. Explanation. Scenario analysis. This scenario presents a common challenge in data center design, where a critical business application's availability is directly tied to the resilience of the underlying infrastructure. The challenge lies in balancing the cost of implementing robust disaster recovery, DR, solutions with the potential financial and reputational impact of an outage. A thorough risk assessment is paramount to ensure that the chosen DR strategy is both effective and economically justifiable, aligning with business objectives and regulatory compliance. The pressure to deliver a cost-effective solution while ensuring business continuity adds a layer of professional complexity. Correct approach analysis. The correct approach involves a multifaceted risk assessment that quantifies the potential impact of various failure scenarios on the critical application. This includes analyzing the likelihood of different types of disruptions, e.g., hardware failure, site-wide outage, cyber attack, and their corresponding recovery time objectives, RTO, and recovery point objectives, RPO. By correlating these impacts with potential financial losses, reputational damage, and regulatory penalties, a clear business case for specific DR investments can be established. This data-driven approach ensures that the design decisions are aligned with the organization's risk tolerance and regulatory obligations, such as those potentially related to data integrity and availability under frameworks like the NIST Cybersecurity Framework. Though specific regulatory frameworks are not mandated for this exam, the principles of risk management are universal. This methodology prioritizes investments in DR capabilities that offer the greatest reduction in overall risk exposure, representing best professional practice by ensuring a strategic and justifiable allocation of resources. Incorrect approaches analysis. Implementing a DR solution based solely on the most expensive, highest availability option without a preceding risk assessment is professionally unacceptable. This approach fails to consider the cost-benefit analysis, potentially leading to overspending on redundant systems that do not significantly improve the overall risk posture for the specific application. It also ignores the possibility that less costly, yet still effective, DR strategies might exist. Choosing a DR solution based primarily on vendor recommendations without independent validation through a risk assessment is another failure. While vendors offer valuable insights, their recommendations may not fully align with the specific risk profile and business requirements of the organization. This can lead to a solution that is either inadequate or unnecessarily complex and expensive. Adopting a DR strategy that prioritizes speed of implementation over thorough risk analysis is also professionally unsound. While time constraints can be a factor, rushing through a risk assessment can result in overlooking critical vulnerabilities or misjudging the potential impact of certain failure scenarios. This can lead to a DR solution that is not fit for purpose and fails to meet the actual business needs or regulatory expectations. Professional reasoning. Professionals should approach DR design by first understanding the critical business functions and applications. Comprehensive risk assessment is the foundational step, involving identification of threats, vulnerabilities, and potential impacts. This assessment should quantify the business impact of downtime, considering financial, operational, and reputational consequences. The results of the risk assessment then inform the selection of appropriate DR strategies, prioritizing those that offer the most effective risk mitigation within the organization's budget and risk tolerance. This process ensures that DR investments are strategic, justifiable, and aligned with business continuity objectives, and any applicable regulatory requirements for data availability and integrity. Question 14. The assessment process reveals a critical vulnerability in the data center's network segmentation, potentially exposing sensitive customer data. The proposed remediation involves a complete overhaul of the existing network architecture, which is estimated to be costly and time-consuming, with a significant risk of service disruption during the transition. The IT security team has presented several alternative mitigation strategies, ranging from immediate but less comprehensive software patches to a phased, more robust architectural redesign. Which of the following approaches best represents a professional and compliant method for addressing this identified vulnerability? Option A. Prioritize the complete architectural redesign, even with its associated costs and risks, to ensure the most robust and future-proof security posture, and defer other security initiatives until this is complete. Option B. Conduct a comprehensive risk assessment that quantifies the likelihood and impact of the vulnerability, evaluates the effectiveness and cost of each proposed mitigation strategy, including the full redesign and phased approaches, and aligns the chosen solution with the organization's risk appetite and regulatory obligations. Option C. Focus on implementing the most cost-effective solution that offers a reasonable level of protection, as determined by the IT security team's initial assessment, to conserve resources for other critical infrastructure projects. Option D. Implement the immediate software patches to address the critical vulnerability as quickly as possible, and postpone any further architectural changes until the next budget cycle, assuming the patches provide sufficient interim protection. The correct answer is A. Prioritize the complete architectural redesign, even with its associated costs and risks, to ensure the most robust and future-proof security posture, and defer other security initiatives until this is complete. Explanation. Scenario analysis. The scenario presents a common challenge in data center design, balancing the need for robust security controls with the operational realities and budget constraints of a business. The assessment process has identified a critical vulnerability, but the proposed remediation involves significant investment and potential disruption. The challenge lies in prioritizing remediation efforts and selecting the most effective and compliant solution within practical limitations. This requires a deep understanding of risk appetite, regulatory requirements, and the potential impact of both the vulnerability and the proposed solutions. Correct approach analysis. The correct approach involves a multifaceted risk assessment that considers the likelihood and impact of the identified vulnerability, alongside the cost and feasibility of various mitigation strategies. This aligns with best practices in data center security and risk management, which emphasize a proactive and informed approach to security. Specifically, it requires evaluating the proposed solution against established security frameworks and regulatory mandates relevant to the data center's operational domain. The goal is to achieve an acceptable level of risk that is both technically sound and economically viable, ensuring compliance with relevant data protection and operational security regulations. This approach prioritizes data integrity, confidentiality, and availability, which are fundamental to maintaining business operations and meeting legal obligations. Incorrect approaches analysis. Implementing a solution without a thorough cost-benefit analysis and a clear understanding of its impact on business operations is a significant regulatory and ethical failure. It can lead to overspending on unnecessary controls or, conversely, underinvesting in critical areas, leaving the organization exposed to unacceptable risks. Ignoring the potential for operational disruption during implementation can lead to service outages, impacting customers and potentially violating service level agreements, SLAs, and regulatory compliance requirements related to service continuity. Furthermore, failing to document the risk assessment process and the rationale behind the chosen solution can hinder future audits and compliance checks, making it difficult to demonstrate due diligence and adherence to regulatory standards. Relying solely on vendor recommendations without independent validation can also be problematic, as it may not fully address the specific risks or regulatory landscape of the organization. Professional reasoning. Professionals should approach such situations by first clearly defining the scope of the risk assessment, identifying all relevant stakeholders, and understanding the organization's risk appetite. This involves gathering comprehensive information about the vulnerability, its potential impact, and the proposed solutions. A structured risk assessment methodology should be employed, considering both qualitative and quantitative factors. The decision-making process should involve evaluating each potential solution against criteria such as effectiveness, cost, operational impact, and compliance with relevant regulations. Documentation is crucial at every stage, from initial assessment to final implementation and ongoing monitoring. Regular review and adaptation of the risk management strategy are also essential to address evolving threats and business needs. Question 15. Consider a scenario where a critical data center component has experienced a security incident, leading to a temporary service disruption. The operations team is eager to restore services as quickly as possible, and there is pressure from management to do so. The lead network engineer proposes to immediately implement a series of security patches and configuration changes based on their immediate understanding of the incident's likely cause, without conducting a formal, in-depth risk assessment of the broader system or involving other departments. Which of the following approaches best aligns with professional risk management principles in this context? Option A. Conduct a comprehensive risk assessment that identifies all potential threats and vulnerabilities related to the incident, evaluates their impact, and informs the remediation strategy, even if it means a slight delay in full service restoration. Option B. Prioritize immediate service restoration by applying the most obvious security patches and configuration changes identified by the operations team, deferring a formal risk assessment until after operations are fully normalized. Option C. Rely on the experience and intuition of senior technical staff to quickly identify and address the most probable security weaknesses without formal documentation or broad consultation. Option D. Focus remediation efforts solely on the specific component that failed, assuming that other parts of the data center infrastructure are not affected by the incident. The correct answer is A. Conduct a comprehensive risk assessment that identifies all potential threats and vulnerabilities related to the incident, evaluates their impact, and informs the remediation strategy, even if it means a slight delay in full service restoration. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for operational continuity with the long-term implications of security vulnerabilities. The pressure to restore services quickly can lead to shortcuts that compromise the integrity of the risk assessment process. Careful judgment is required to ensure that the risk assessment is thorough and not unduly influenced by operational urgency. The correct approach represents best professional practice because it prioritizes a systematic and documented evaluation of potential threats and vulnerabilities. By engaging relevant stakeholders and considering the business impact, the organization adheres to principles of due diligence and responsible risk management. This aligns with general IT governance best practices, which emphasize a proactive and comprehensive approach to security. While the 300-610 DCID exam focuses on technical design, the underlying principles of risk assessment are fundamental to designing resilient and secure infrastructure. A robust risk assessment informs design decisions, ensuring that controls are proportionate to the identified risks. An incorrect approach that focuses solely on immediate threat mitigation without a broader risk assessment fails to address the root causes of vulnerabilities. This can lead to a false sense of security and leave the organization exposed to other unaddressed risks. Ethically, this is a failure of due care, as it neglects a systematic evaluation of potential harm. Another incorrect approach that relies on anecdotal evidence or the opinions of a limited group of individuals lacks the rigor necessary for effective risk management. This can result in biased assessments and the overlooking of critical risks. Professionally, this demonstrates a lack of adherence to established risk assessment methodologies. A third incorrect approach that delays the risk assessment until after remediation is completed is fundamentally flawed. This means that remediation efforts may not be optimally targeted, potentially wasting resources, or failing to address the most significant risks. This represents a failure in the planning and execution phases of risk management. The professional decision-making process for similar situations should involve a structured approach to risk assessment. This includes identifying assets, threats, and vulnerabilities, analyzing the likelihood and impact of potential risks, evaluating existing controls, and determining appropriate mitigation strategies. It is crucial to involve a diverse group of stakeholders, including technical experts, business owners, and compliance officers, to ensure a comprehensive perspective. Documentation of the entire process is essential for accountability and future reference. When faced with operational pressure, it is important to communicate the necessity of a proper risk assessment and to advocate for the time and resources required to conduct it effectively, even if it means a slight delay in immediate remediation. Question 16. The investigation demonstrates that a financial services organization is designing a new data center infrastructure and must select a network virtualization technology. The primary drivers for the design are high performance, scalability, and adherence to strict financial industry regulations regarding data privacy, security, and auditability. The design team is evaluating several options, each with varying levels of advanced features and associated costs. Which of the following approaches best aligns with professional best practices for designing a compliant and effective data center network virtualization solution in this regulated environment? Option A. Choose a network virtualization technology based on its widespread adoption and positive reviews from industry peers, without a specific deep dive into how its features map to the organization's unique regulatory obligations. Option B. Prioritize the network virtualization technology that offers the most advanced features and highest performance metrics, assuming that superior technology inherently satisfies regulatory requirements. Option C. Select the network virtualization technology with the lowest upfront cost, as cost efficiency is a key objective for the organization, and address compliance concerns through post-implementation security controls. Option D. Engage with the organization's compliance and legal departments to thoroughly understand all regulatory mandates. Conduct a detailed risk assessment of potential virtualization solutions against these mandates, and select a technology that demonstrably meets both technical and compliance requirements. The correct answer is B. Prioritize the network virtualization technology that offers the most advanced features and highest performance metrics, assuming that superior technology inherently satisfies regulatory requirements. Explanation. The investigation demonstrates a common challenge in data center design, balancing the need for robust, high-performance infrastructure with the imperative to adhere to evolving regulatory compliance requirements. Specifically, the scenario highlights the complexities of selecting appropriate network virtualization technologies in a regulated environment where data integrity, security, and auditability are paramount. The professional challenge lies in interpreting and applying the relevant Cisco data center design principles and best practices in conjunction with the specific regulatory framework governing the organization's operations, ensuring that the chosen solution not only meets technical performance goals, but also satisfies all compliance mandates without introducing undue risk or operational overhead. The correct approach represents best professional practice because it prioritizes a thorough understanding of both the technical capabilities of network virtualization solutions and the specific regulatory obligations. By engaging with compliance officers and conducting a detailed risk assessment that maps technical features to regulatory controls, the design team ensures that the chosen solution is not only technically sound, but also demonstrably compliant. This proactive, collaborative, and risk-informed methodology aligns with the principles of responsible data center design, emphasizing due diligence and the integration of compliance as a foundational element rather than an afterthought. This approach minimizes the likelihood of costly redesigns, audit failures, and potential legal or financial penalties. An incorrect approach that focuses solely on the lowest cost option without a comprehensive compliance review represents a significant regulatory and ethical failure. It prioritizes short-term financial gains over long-term compliance and security, potentially exposing the organization to breaches, data loss, and non-compliance penalties. This demonstrates a lack of due diligence and a failure to uphold the professional responsibility to design secure and compliant systems. Another incorrect approach that selects a technology based on vendor marketing claims without independent verification or a clear understanding of its integration with existing compliance frameworks is also professionally unacceptable. This approach relies on unsubstantiated assertions and neglects the critical step of validating technical capabilities against specific regulatory requirements, leading to potential gaps in security and auditability. It signifies a failure to apply critical thinking and a reliance on potentially misleading information, which can have severe compliance repercussions. Finally, an approach that delays compliance considerations until after the technical design is finalized is a recipe for disaster. This reactive stance often leads to expensive and disruptive retrofitting of security and auditing features, or worse, the adoption of a technically suboptimal solution simply to meet compliance deadlines. It represents a fundamental misunderstanding of the integrated nature of data center design and compliance, failing to embed regulatory requirements into the core design process. The professional reasoning process for similar situations should involve a structured, multidisciplinary approach. First, clearly define the regulatory landscape and identify all applicable compliance mandates. Second, engage stakeholders from compliance, security, and operations early in the design process. Third, conduct a thorough technical evaluation of potential solutions, explicitly mapping their features and capabilities against identified regulatory controls. Fourth, perform a comprehensive risk assessment for each viable option, considering both technical and compliance risks. Fifth, document the decision-making process, including the rationale for the chosen solution and the mitigation strategies for any identified risks. This systematic approach ensures that technical excellence and regulatory adherence are achieved concurrently. Question 17. Upon reviewing the initial design proposal for a new data center fabric, a key stakeholder has requested a significant increase in the expected throughput for a critical application, citing a recent industry trend. The proposal currently relies on a well-established but potentially less cutting-edge network architecture. What is the most professional and compliant approach to address this request? Option A. Conduct a thorough performance analysis of the proposed architecture under the new throughput requirements. Explore alternative design patterns and technologies that can meet the increased demand while maintaining resilience and manageability, and document the trade-offs of each viable option before making a final recommendation. Option B. Implement the requested throughput increase by simply over-provisioning existing link capacities, without a detailed analysis of the impact on latency, congestion, and overall fabric stability. Option C. Inform the stakeholder that the current design is based on proven technologies and that deviating from it based on a trend is not advisable, without exploring the feasibility of the request. Option D. Immediately revise the design to incorporate the latest high-speed proprietary switching hardware from a leading vendor, assuming this will inherently satisfy the increased throughput requirement without further investigation. The correct answer is A. Conduct a thorough performance analysis of the proposed architecture under the new throughput requirements. Explore alternative design patterns and technologies that can meet the increased demand while maintaining resilience and manageability, and document the trade-offs of each viable option before making a final recommendation. Explanation. This scenario presents a common challenge in data center design, balancing performance requirements with the need for robust and compliant infrastructure. The professional challenge lies in interpreting vague requirements and translating them into concrete design decisions that adhere to established best practices and, crucially, the regulatory framework relevant to the exam's jurisdiction. The Cisco 300-610 DCID exam focuses on designing data center infrastructure, implying a need to consider not just technical feasibility, but also operational efficiency, security, and compliance. The correct approach represents best professional practice because it prioritizes a systematic, evidence-based methodology. It involves understanding the underlying business and technical drivers for the performance requirement, validating assumptions through testing and analysis, and then selecting a solution that demonstrably meets the need while adhering to design principles like scalability, resilience, and manageability. This aligns with professional engineering ethics which mandate competence, due diligence, and the provision of reliable and safe solutions. Specifically, within the context of data center design, this approach ensures that the infrastructure is not only functional but also sustainable and meets any implicit or explicit service level agreements or regulatory mandates related to availability and performance. An incorrect approach that focuses solely on a single vendor's proprietary solution without independent validation or consideration of alternatives fails to demonstrate due diligence. This could lead to vendor lock-in, suboptimal performance, and increased long-term costs. Ethically, it may also represent a failure to act in the best interest of the client or organization by not exploring the full range of viable options. Another incorrect approach that prioritizes the cheapest available solution without adequate performance or reliability assessment is professionally unsound. This can lead to frequent outages, data loss, and significant business disruption, violating the professional obligation to deliver a fit-for-purpose solution. A third incorrect approach that relies on anecdotal evidence or common practice, without rigorous analysis, risks implementing a design that is not optimized for the specific environment or may not meet future demands, potentially leading to compliance issues if performance targets are not met consistently. The professional decision-making process should involve a thorough requirements gathering phase, followed by a comparative analysis of potential solutions. This analysis should consider technical merit, cost-effectiveness, scalability, resilience, security, and compliance with relevant standards and regulations. Proof-of-concept testing and pilot deployments are valuable tools to validate design choices before full implementation. Question 18. Process analysis reveals that a new data center infrastructure is required to support evolving business applications and an increasing volume of data. Without a definitive budget or detailed application performance metrics, which design approach best aligns with Cisco's data center design principles for long-term scalability and operational efficiency? Option A. Design for maximum redundancy and incorporate the most advanced features available across all layers of the infrastructure to ensure unparalleled resilience and performance, regardless of immediate application needs. Option B. Implement a modular building block architecture that allows for incremental scaling of compute, storage, and network resources, incorporating automation and orchestration capabilities from the outset. Option C. Prioritize the lowest initial capital expenditure by selecting the most cost-effective hardware components, deferring any potential upgrades or expansions until absolutely necessary. Option D. Focus on a highly customized, bespoke network and server configuration tailored to the current perceived needs of the most critical applications, with minimal consideration for future integration or standardization. The correct answer is B. Implement a modular building block architecture that allows for incremental scaling of compute, storage, and network resources, incorporating automation and orchestration capabilities from the outset. Explanation. This scenario presents a professional challenge in designing a data center infrastructure that balances performance, scalability, and cost-effectiveness, while adhering to specific Cisco design principles and best practices relevant to the DCID exam. The challenge lies in evaluating different architectural approaches without the benefit of a fully defined operational requirement or budget, forcing a reliance on generalized best practices and anticipated future needs. Careful judgment is required to select an approach that is not only technically sound, but also justifiable from a long-term operational and investment perspective. The correct approach represents best professional practice because it prioritizes a modular and scalable design that aligns with Cisco's recommended data center architectures, such as the Cisco Validated Design, CVD, for data centers. This approach emphasizes building blocks that can be independently scaled and managed, reducing complexity and risk. It also considers the integration of automation and orchestration tools from the outset, which is crucial for efficient data center operations and future growth. Adhering to these principles ensures that the design is robust, adaptable, and cost-effective over its life cycle, minimizing the need for disruptive re-architectures. This aligns with the professional responsibility to deliver sustainable and efficient infrastructure solutions. An incorrect approach that focuses solely on the lowest initial capital expenditure without considering scalability or operational efficiency represents a failure in professional judgment. This can lead to significant hidden costs in the future due to performance bottlenecks, the inability to accommodate growth, and increased operational overhead. Ethically, it fails to serve the long-term interests of the organization by prioritizing short-term savings over sustainable infrastructure. Another incorrect approach that over-engineers the solution with excessive redundancy and advanced features that are not immediately required, without a clear business justification, is also professionally unsound. This leads to unnecessary capital expenditure and increased complexity in management and maintenance. It demonstrates a lack of understanding of the organization's actual needs and a failure to apply the principle of designing for current requirements with a clear path for future expansion. This can be seen as a misallocation of resources and a failure to act as a responsible steward of organizational assets. A third incorrect approach that neglects the integration of automation and orchestration tools, opting for manual configuration and management, fails to embrace modern data center operational paradigms. This leads to inefficiencies, increased risk of human error, and a significant impediment to agility and scalability. Professionally, it represents a failure to stay current with industry best practices and to design for an efficient and resilient operational environment. The professional reasoning process for similar situations should involve a thorough understanding of the organization's current and projected business needs, a deep knowledge of available technologies and Cisco's recommended design principles, and a balanced consideration of capital expenditure, operational expenditure, scalability, and manageability. It requires a consultative approach, engaging with stakeholders to define requirements and constraints, and then applying a structured design methodology to evaluate and select the most appropriate architectural approach. Question 19. Examination of the data shows that a proposed security enhancement for a financial data center involves deploying advanced intrusion detection and prevention systems, IPS, across all network segments, along with a significant increase in hardware for data encryption at rest and in transit. While these measures are intended to bolster security, the projected cost is substantial, and there is concern about potential performance degradation. The design team needs to determine the most appropriate approach to evaluate and implement these security measures. Option A. Reject the proposed security enhancements due to the high cost and potential performance degradation, and instead rely on existing security measures and standard firewall configurations, assuming they are sufficient for current threats. Option B. Implement all proposed security enhancements immediately to ensure maximum protection, as the organization handles sensitive financial data, and any compromise would be catastrophic, regardless of cost or performance impact. Option C. Adopt the proposed security enhancements based on a general understanding of common security best practices for financial institutions, without conducting a specific risk assessment for this particular data center environment. Option D. Conduct a comprehensive threat modeling and risk assessment exercise to identify specific vulnerabilities and prioritize security controls based on their effectiveness and impact, justifying the proposed enhancements against identified risks and organizational risk tolerance. The correct answer is D. Conduct a comprehensive threat modeling and risk assessment exercise to identify specific vulnerabilities and prioritize security controls based on their effectiveness and impact, justifying the proposed enhancements against identified risks and organizational risk tolerance. Explanation. Scenario analysis. The scenario presents a common challenge in data center design, balancing the need for robust security with operational efficiency and cost-effectiveness. The data center is handling sensitive financial data, which inherently demands a high level of security. However, the proposed solution involves a significant increase in hardware, potentially impacting performance and budget. The professional challenge lies in evaluating the proposed security enhancements against the actual threat landscape and the organization's risk tolerance, ensuring that the chosen solution is both effective and justifiable. Correct approach analysis. The correct approach involves a thorough risk assessment and threat modeling exercise. This process, aligned with industry best practices for data center security and compliance frameworks, such as those referenced in Cisco's DCID curriculum, which implicitly assumes adherence to general data protection principles and security standards common in regulated industries, identifies specific vulnerabilities and the likelihood and impact of potential threats. Based on this assessment, a layered security strategy is developed, prioritizing controls that offer the most significant risk reduction for the investment. This approach ensures that security measures are proportionate to the identified risks, avoiding over-provisioning or under-provisioning of security controls. It also facilitates a clear justification for security investments to stakeholders, demonstrating due diligence and a data-driven decision-making process. Incorrect approach is analysis. One incorrect approach is to implement all proposed security enhancements without a prior risk assessment. This represents a failure in professional judgment by not applying a risk-based methodology. It can lead to unnecessary expenditure on security controls that do not address the most critical threats, while potentially leaving the data center vulnerable to overlooked risks. Ethically, it can be seen as a misuse of organizational resources. Another incorrect approach is to dismiss the proposed security enhancement solely based on cost without a proper evaluation of the potential impact of a security breach. This demonstrates a failure to understand the organization's risk appetite and the potential financial, reputational, and legal consequences of a security incident, especially when dealing with sensitive financial data. It prioritizes short-term cost savings over long-term security and compliance, which is professionally unsound and potentially non-compliant with data protection regulations. A third incorrect approach is to rely on anecdotal evidence or industry buzzwords for security solutions, without validating their effectiveness against the specific data center environment and threat profile. This lacks the rigor required for professional data center design and can lead to the adoption of ineffective or even detrimental security measures. It bypasses the critical step of verifying that proposed solutions directly address identified risks. Professional reasoning. Professionals should adopt a systematic, risk-based approach to data center security design. This involves 1. Understanding the data and its sensitivity. 2. Identifying potential threats and vulnerabilities relevant to the data center's environment and the data it protects. 3. Assessing the likelihood and impact of these threats. 4. Prioritizing security controls based on the risk assessment, considering effectiveness, cost, and operational impact. 5. Documenting the rationale for all design decisions, including security measures, to ensure accountability and facilitate future reviews. 6. Continuously monitoring and adapting security measures as the threat landscape evolves. Question 20. Performance analysis shows that a new network fabric configuration designed to improve traffic flow efficiency is ready for deployment across a large, multi-site data center. The proposed configuration has been thoroughly tested in a lab environment and appears to meet all performance objectives. However, the data center operates critical financial services with zero tolerance for downtime. What is the most professional and risk-averse approach to implementing this new fabric configuration? Option A. Deploy the new configuration to a single, isolated data center site first, and if successful, replicate the deployment process to other sites without further validation at each individual site. Option B. Implement the new configuration across all leaf switches in the data center simultaneously to ensure immediate and uniform application of the improved traffic flow. Option C. Postpone the implementation indefinitely until further, more extensive testing can be conducted, as the risk of even minor disruption to financial services is unacceptable. Option D. Deploy the new configuration to a small, non-critical segment of the fabric first, monitor its performance and stability closely, and then proceed with a phased rollout to the remaining segments based on successful validation. The correct answer is D. Deploy the new configuration to a small, non-critical segment of the fabric first, monitor its performance and stability closely, and then proceed with a phased rollout to the remaining segments based on successful validation. Explanation. This scenario presents a common implementation challenge in data center design, ensuring consistent and reliable network fabric behavior across a distributed environment. The professional challenge lies in balancing the need for rapid deployment with the imperative to maintain stability and adhere to design principles that prevent cascading failures. Careful judgment is required to select an implementation strategy that minimizes risk while maximizing operational efficiency. The correct approach represents best professional practice because it prioritizes a phased, controlled rollout of configuration changes. This aligns with established ITIL principles for change management, emphasizing risk mitigation through testing and validation in a controlled environment before broad deployment. Specifically, It adheres to the spirit of regulatory frameworks that mandate due diligence in system changes to prevent service disruption and data integrity issues. By validating the configuration on a subset of the fabric, the design team can identify and rectify potential issues without impacting the entire production environment, thus upholding the principle of least privilege and minimizing the blast radius of any unforeseen problems. This methodical approach also supports auditability and compliance by providing a clear trail of testing and validation steps. An incorrect approach that involves deploying the new configuration to all leaf switches simultaneously without prior validation in a staging environment represents a significant regulatory and ethical failure. This is because it disregards the fundamental principle of risk management inherent in any infrastructure change. Such an action could lead to widespread network instability, service outages, and potential data loss, violating implicit or explicit service level agreements, SLAs, and potentially contravening regulations that require the maintenance of business continuity and data integrity. It demonstrates a lack of professional responsibility by prioritizing speed over safety and thoroughness. Another incorrect approach, which is to delay the implementation indefinitely due to fear of disruption, also presents professional shortcomings. While caution is necessary, an indefinite delay can lead to the data center infrastructure falling out of compliance with security best practices or performance benchmarks, potentially exposing the organization to vulnerabilities or operational inefficiencies. This inaction can be seen as a failure to proactively manage the infrastructure and meet evolving business or regulatory requirements. The professional decision-making process for similar situations should involve a structured risk assessment for any proposed change. This includes identifying potential impacts, developing mitigation strategies, and defining clear rollback procedures. A phased implementation, starting with a pilot group or staging environment, followed by incremental rollout to production, is a cornerstone of responsible infrastructure management. Professionals must balance the urgency of business needs with the critical requirement for stability, security, and compliance, always erring on the side of caution when potential for widespread disruption exists.